Welcome back, students. Today in this session we are going to study chapter number 13, surface areas and volumes. So in this chapter you are going to study about surface areas and volumes of solid figures like cube, cuboid, cylinder, cone and sphere. So by cylinder and cone we mean the right circular cylinder and the right circular cone. So let us first study the surface areas and volumes of a cube and a cuboid. First of all, let us understand about cuboid. As you know, a cuboid is made up of 6 rectangular faces in which the opposite faces are of equal dimension, that is of equal area. If this is the length, this is the breadth, and this is the height, then the surface area of this cuboid will be the area of that 6 rectangular faces making up this cuboid. And as you know, the opposite faces are of equal area. That is, the right face will be equal to the left face, top face will be equal to the bottom face, and the front face will be equal to the back face. So the surface area will be the area of these six rectangular faces. So considering the front face, the area will be laying into height. The back face will also be laying into height. So the area of this back and the front face will be 2 times laying into height, plus the area of this right face and the left face will be 2 times breadth into height, and the area of the top and bottom will be 2 times length into breadth, that is length into breadth. So the total surface area of a cuboid will be 2 times length into breadth plus breadth into height plus height into length, and the volume of a cuboid will be given by length into breadth into height. Now let us study about cube. As you know, cube is made up of 6 square faces. 6 square faces. So if this is the A is the length of a cube, then the breadth will also be A, of length A, and the height will be also of length A. So the surface area will be the area of the 6 square faces, that is 6 A into A, that is A square, 6 times A square, and the volume will be A into A, that is length into breadth into height. So A into A is A cube. So the surface area of a cube will be given by 6A square, and the volume will be given by A cube. Next, let us study about right circular cylinder. So in a right circular cylinder, there are two equal circles at the top and the bottom, and the lateral surface is of curve. It is made up of curved rectangular shape. So if R is the radius of these two equal circle and H is the height of the right circular cylinder, then let us find the curved surface area. That is the area of this portion of this right circular cylinder. Suppose if we cut the right circular cylinder at this portion, then we will get two equal circles at the top and the bottom, and one rectangular shape which is rolled off to form the curved surface area of the cylinder. So the curved surface area will be the area of this rectangular shape figure. So the length of this rectangular will be the circumference of this circle, which is 2 pi r, and the breadth will be the height of the right circular cylinder. So the curved surface area will be given by laying into breadth, that is 2 pi r h, and the total surface area will be equal to the curved surface area plus the area of these two equal circles. So the area of a circle is given by pi r square. Since there are two equal circles, we multiply by 2. This will be equal to curved surface area is 2 pi r h plus 2 pi r square, equal to, this will be 2 pi r h plus r, which can be written as r plus h. So the total surface area of a right circular cylinder is 2 pi r within bracket r plus h, and the volume of the right circular cylinder will be given by area of the circular base into height of the right circular cylinder. Area of the circular base will be pi r square into height will be h. So this will be pi r square h. So the volume of a right circular cylinder is pi r square h. So for a right circular cylinder, the curved surface area is given by 2 pi r h, and the total surface area is given by 2 pi r and within bracket r plus h, and the volume of a right circular cylinder is given by pi r square h. Next, let us study about right circular cone. So if in a cone, r is the radius of the cone and h is the height of the cone, and l is the slant height of the cone, then the curved surface area of a right circular cone is equal to pi r l. So the curved surface area is given by pi r l, and the total surface area of a cone will be equal to the curved surface area plus curved surface area is pi r l plus the area of this circular top. That is, the area of this will be pi r square. So the total surface area of a cone will be pi r l plus r, and the volume of a cone will be given by 1 by 3 pi r square h. So in a right circular cone, this angle will be 90 degree. So in this right triangle, by Pythagoras theorem, the slant height L square will be h square, height of the cone, plus r square, that is square of the radius. So in a right circular cone, the square of the slant height will be equal to the sum of the square of the height plus radius square. Next, we will study the surface area and volume of a sphere. So if r is the radius of a sphere, then the surface area of a sphere is given by 4 pi r square. And if we consider half of a sphere, that is hemisphere, the curved surface area, this will be r. The curved surface area of a hemisphere, hemisphere will be half of the surface area of a whole sphere. That is, the half of it, this will be 2 pi r square, and the total surface area of a hemisphere of a hemisphere will be uh, the sum of the curved surface area 2 pi r square, sum of the curved surface area plus the area at the base, which is in the form of a circle. If we cut the cut a sphere into half, then the bottom will be in the form of a circle. So the total surface area of a hemisphere will be the sum of curved surface area plus the base, which is in the form of a circle. So that will be pi r square. So the total curved surface area will be 3 pi r square. Now let us study about the volume of a sphere. Volume of a sphere is given by 4 by 3 pi r cube. So the volume of a hemisphere will be half of this, that is 2 by 3 pi r cube. Exercise 13.1, question number 1. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is open at the top, ignoring the thickness of the plastic sheet. Determine Roman number 1, the area of the sheet required for making the box, and Roman number 2, the cost of sheet for it if a sheet measuring 1 meter square costs rupees 20. So question number 1, solution. In the question it is mentioned that we are to make a plastic box which is in the shape of a cuboid and its dimensions are 1.5 meter long, 1.25 meter wide and 65 centimeter deep. So we are to make a plastic box which is 1.5 meter long and 1.25 meter wide, and then the height of the box is 65 centimeter. It is open at the top, that is, this part is open, and we are to determine the area of the plastic sheet required to make this box. So let us first find the area of this box, surface area of this box, and that will be the required area of the plastic sheet required to make the box. So if the top portion of the box is open, so we are going to exclude that area from the total surface area. So let us first write down the given information. So here length L equal to 1.5 meter, breadth equal to 1.25 meter, and then height h is equal to 65 centimeter, which is equal to 0.65 meter. Now let us find the surface area required. Let us sum up this as required area of the sheet equal to, since the top part is open, the required surface area of the box will be length to breadth, 1 time of the length to breadth, because we are excluding this part and including only the bottom part. So there will be 1 time length to breadth plus 2 times breadth into height plus height into length. This is equal to, our length is 1.5 into breadth is 1.25 plus 2 times breadth is 1.25 into height is 0.65 plus 0.65 into length, that is 1.5. This implies this is equal to 1.875 plus 2 times, let me take out this 0.65 as common and add this 1.25 with 1.5, and this will be equal to 2.75. This is equal to 1.875 plus 2 into 0.65 is 1.3 into 2.75, which is equal to 1.875 plus 1.3 into 2.75 is equal to 3.575. Now adding this 2, we will get 5.45 meter square. Therefore, the required area of the sheet to make the plastic box is 5.45 meter square. This is the first part of the question. Now let us try to solve the second part. Second part says to find the cost of the sheet if a sheet measuring 1 meter square costs rupees 20. Now the cost of this sheet is equal to rupees, per meter square it costs rupees 20. So for 5.45 meter square, we are going to multiply by rupees 20, which becomes rupees 109. So the required amount is rupees 109. Next, exercise 13.1, question number 7. Shanti's switch stall was placing an order for making cardboard boxes for packing their switch. 2 sizes of boxes were required. The bigger of dimensions 25 cm into 20 cm into 5 cm, and the smaller of dimension 15 cm into 12 cm into 5 cm. For all the overlaps, 5% of the total surface area is required extra. If the cost of the cardboard is rupees 4 for 1000 centimeters square, find the cost of cardboard required for supplying 250 boxes of its kind. So exercise 13.1, question number 7, solution. Let us first find the surface area of the 2 boxes. That is, first of all, let us find the surface area of the bigger box. Surface area of the bigger box. The box is in the shape of cuboid, so we'll use the formula for the surface area of the cuboid, that is 2 times length into breadth. The dimension of the bigger box is 25 centimeter into 20 centimeter into 5 centimeter. So the surface area of the bigger box will be 2 times length into breadth, that is 25 into 20 plus breadth into height 20 into 5 plus, and then height into length, so 5 into 25. This will be centimeter square. This is equal to 2 times 25, 20 times is 500 plus 20 into 5 is 100 plus 5 into 25 is 125 centimeter square. This is equal to 2 times into 500, 600 plus 125, 725 centimeter square. This is equal to 1450 centimeter square. Now for the smaller box. So surface area of the smaller box. The dimension of the smaller box is 15 centimeter into 12 centimeter into 5 centimeter. So the surface area will be 2 times plane to breadth, that is 15 into 12 plus 12 into 5 plus 5 into 15. This will be centimeter square. This is equal to 2 times 15 into 12 is 180 plus 12 5 times is 60 plus 5 times 15 is 75 centimeter square. This is 2 times 315. This is equal to centimeter square. This is equal to 630 centimeter square. Next, we will find the surface area of both the boxes, that is the bigger one and the smaller one. So surface area of the two boxes is equal to 1450 plus 630 centimeters square, which is equal to 2080 centimeters square. Now to the next step, that is to find the area of the overlap. So to find the area of the overlap, it is mentioned in the question that it is the overlap is of 5% of the total surface area. So surface area of the overlap is equal to 5% of the total area. That is 5% of 2080 centimeters square, equal to 5 by 100 into 2080. This is 2 times. This 208 divided by 2 is 104 centimeter square. Next, we will add this surface area of the overlap to this surface area of each of the two boxes to find the total surface area. Total surface area of the two boxes is equal to 2080 plus 104 centimeter square, which is equal to 2184 centimeter square. Next, we will find the total surface area of 250 boxes, equal to 2184 into 250 centimeter square. Next, let us find the cost of the cardboard required. Therefore, cost of the cardboard required. Cost of the cardboard required equal to, it is given in the question that per 1000 centimeter square, the cost of the cardboard is ₹4. So we are going to divide the total surface area of the 250 box by 1000 and then multiply by 4. So the total surface area of 250 boxes is 2184 multiplied by 250. This will be divided by 1000 as the price is for per 1000 centimeter square, and then multiplied by 4. For every per 1000 centimeter square, the price is ₹4. So let us calculate this and find out what is the cost of the cardboard required. So 250 4 times is 1000, and this 4 and this 4 will be cancelled. So the required amount is, that is the cost of the cardboard required, is rupees 2184. Next, exercise 13.2, question number 1. The curved surface area of a right circular cylinder of height 14 centimeter is 88 centimeters square. Find the diameter of the base of the cylinder. Exercise 13.1, question number 1, solution. So in the question, it is given that the height of the right circular cylinder is 14 centimeter, and the curved surface area of the cylinder is 88 centimeters square. We are to find the diameter of the cylinder. So we know that the curved surface area of a right circular cylinder is given by 2 pi r h. This implies where r is the radius of the circular cylinder. So the curved surface area is 88 equal to 2. We will use pi as 22 by 7. The value of pi is 22 by 7 into r into h. H is 14 centimeter. So if we find the value of r, we can easily find the value of d, that is the diameter. This implies this 7 and this 14, this 2 times. So r will be 88 divided by 2 into 22 into 2. So 22 4 times is 88, and this 2 and this 2 will get cancel each other, and this will remain as 1. So the value of r is 1. Therefore r equal to 1 centimeter. As you all know, hence diameter is equal to 2 times of r. And this implies this is equal to, diameter will be 2 times that of r, that is r is 1. This will be equal to 2 centimeter. So the diameter of the right circular cylinder will be 2 centimeter. Exercise 13.2, question number 9. Find Roman number 1, the lateral or curved surface area of a closed cylindrical petrol storage tank that is 4.2 meter in diameter and 4.5 meter high. Roman number 2, how much steel was actually used if 1 by 12 of the steel actually used was wasted in making the tank? Exercise 13.2, question number 9, solution. First, let us find the curved surface area. So the given information is the diameter of the petrol storage is, the diameter is 4.2 meter. Therefore, r is equal to d by 2, that is half of diameter, equal to 4.2 meter by 2 equal to 2.1 meter. Now, the curved surface area of the petrol tank is equal to, since it is in the form of a cylindrical shape, therefore we are going to use the formula for curved surface area, that is 2 pi r h. And also the height of the tank is given as how much? 4.5 meter. So the curved surface area equal to 2 into the value of pi is 22 by 7, r is 2.1 into, and the height is 4.5 meter. This will be meter square, equal to 7 and 2.1 will be 0.3. 7 divides 2.1 and we will get 0.3. 2 into 4.5 will be 9. So 22 into 0.3 into 4.5, 2 times is 9 meter square. This is equal to 9 2 are 18, 1 carry, 9 2 are 9, 9 2 are 18, 1 carry and will become 19 into 0.3 meter square. This will be 3 times is 24, 2 carry, 9 3 are 27, 29, 2 carry, 3 times 2 is 5. And the decimal place will be, so 59.4 meters square will be the curved surface area of the petrol tank. Now for the second part is for Roman number 2. We have to find the total surface area of the actual amount of the steel used in making that petrol tank, where it is mentioned that 1/12 of the total steel actually used was wasted in making that tank. So first let us find the total surface area of the petrol tank. So total surface area will be equal to 2 pi r by r plus h. Let us substitute this value. This will be 2 pi r square plus 2 pi r h. This is equal to 2 into pi value is 22/7 into r is 2.1. So 2.1 into 2.1 plus 2 pi rh is the curved surface area of the tank. So this is 59.4 and the unit will be meter square, equal to, this will be 0.3 as it is same as before. So 22 into 2 is 44 and 0.3 into 2.1 will be how much? 0.63 plus 59.4 meter square. This is equal to 44 times 0.63 is 27.72 plus 59.4 meter square, equal to this is 87.12 meter square. So the total surface area of the storage tank is 87.12 meter square, but we are to find the actual amount of steel used in making this tank, in which out of this actual steel use 1/12 is wasted. So let x meter square be the actual steel use. Then by question we have actual steel use, that is x minus 1/12 of the actual steel use, that is 1/12 of x, 1/12 of x, let me write like this, is equal to the total surface area of the storage tank, which is 87.12. This is the amount of steel wasted, and this is the actual steel use. The difference between this is the total surface area of the petrol tank. Let us solve this. Let us find the value of x from this equation, and we will get the total actual steel use. This will be implies x minus x by 12 equal to 87.12. This is 12 minus x. Let us take the LCM. So the numerator will be 12 minus x, which is 11 times x equal to 87.12. This implies x is equal to 87.12 into 12 by 11, which is equal to, here 87.12 is actually divisible by 11. It will be how many times? 7, 11 7 times 77, 101, so 0.9 and 2. So 87.12 divided by 11 is 7.92 into 12 times, which is equal to 95.04. So the total actual still use is 95.04 meter square. Hence, the actual still uses 95.04 meter square. Next, exercise 13.2, question number 11. The students of a Vidyalaya were asked to participate in a competition for making and decorating pen holders in the shape of a cylinder with a base using cardboard. Each pen holder was to be of radius 3 cm and height 0.5 cm. The Vidyalaya was to supply the competitors with cardboard. If there were 35 competitors, how much cardboard was required to be bought for the competition? Next, exercise 13.2, question number 11. In the question, it is mentioned that 35 competitors are participating in a competition of making pen holders. The pen holders is in the form of a right circular cylinder in which the radius of the base is 3 cm and the height of the cylinder is, that is the pen holder, is 10.5 cm. As you know, this is a pen holder. The top part will be open, so we are going to find the total surface area of this pen holder excluding the top portion, which is in the form of circle. So let us first write down the given information. Given radius of the pen holder is 3 cm and that of the height of the pen holder is 10.5 cm. Let us first find the total surface area of one pen holder, which is equal to the curved surface area of this pen holder will be given by 2 pi r h plus the area of the base, which is in the form of circle, that is pi r square. The top part will be excluded because the surface area of the top part will be excluded because this will be open as it is a pen holder. So we will find only the surface area of this base, which is pi r square. So equal to, this will be, let us find this value. First, let us take the common part, it is pi and r. Let us take pi r as the common. Then within the bracket, we will get 2h plus and here r. Let us put all these values. Pi will be 22 by 7 and r is 3. And within the bracket, 2 into height is 10.5 plus r is 3. This will be centimeter square, equal to 22 into 3 times is 66 by 7 into, this will be 10, 2 times 10 is 20 and that 0.5 2 times is 1, so it will be 21 plus 3. centimeter square, equal to 66 by 7 into 363. 21 plus 3 is 24 centimeter square, which is equal to 66 24 times is 1584 by 7 centimeters square. Let us keep the value as it is, and now let us find the total surface area of 35 pen holders. So total surface area of 35 pen holders will be equal to 1584 by 7 multiplied by 35. This will be centimeter square. This is 5 times is 35, and this will be equal to 7920 centimeter square. So the total surface area of cardboard required to be bought for the competition is 7920 centimeter square. Hence 7920 centimeter square of cardboard is required for the competition.